You know that feeling, right? We've all been there.
Oh, absolutely.
You're alone in the house, you walk out of a bright room into, say, a totally dark hallway, and for just a split second, you see something.
A shape.
Yeah, a shape, or even worse, it looks like a pair of eyes, or a whole face just looking back at you.
And then it's gone the second you actually focus. But that spike of terror is very, very real.
It's so real. Even when your logical brain is screaming, there's nothing there, your eyes or your mind are telling you something completely different.
It's a truly primal and universal cognitive glitch we all experience. It just bypasses all reason and goes straight for that emotional core.
Right. And that is exactly our mission for this deep dive. We're taking the sources you brought and we're going to figure this out. The big question is, can the brain really make you literally see detailed human features, full-on faces, from nothing but shadows?
And if so, how does that work? And to get to the how, we have to start with the main scientific term for this. It's called pareidolia.
Pareidolia. Okay, I've heard of this. That's like seeing Jesus on a piece of toast or a rabbit in the clouds, that kind of thing.
That's the one. But when you apply it to darkness, it stops being this sort of cute, funny thing, and it becomes genuinely unnerving.
Yeah, it does.
Pareidolia is essentially the brain's pattern matching engine running in overdrive. And in a dark room, the visual information is, well, it's profoundly insufficient.
There's nothing to work with.
Exactly. So the brain goes into this kind of data recovery mode. It hates ambiguity. So instead of just seeing a fuzzy blob, it defaults instantly to the fastest and most biologically critical shape it knows.
And that's the human face.
That is universally the human face.
Okay, let's unpack that, because that feels like the crucial part. Why the face? If the brain is just trying to fill in gaps, why doesn't it make you see a box or a car or anything else? Why is it always a face?
That's where we get into some really specialized neurological hardware. See, the research shows that recognizing faces isn't done by the brain's general visual processor. We actually have a dedicated area for it.
A dedicated area?
Yep, it's called the fusiform gyrus, and its whole job is rapid-fire facial identification.
So it's not just a general system running, it's like a dedicated factory that only makes faces.
That's a great way to put it, a face factory. And this programming is fundamental. We are wired from the moment we are born to recognize faces. It's vital for communication, for threat assessment, social bonding.
So in a confusing environment, finding a face is job number one.
It is the highest priority. The brain wants to know immediately. Is that someone I know? Are they looking at me? Are they a threat?
So the fusiform gyrus has a standing order.
Right.
When the data is bad, find a face, no matter what.
Precisely. And in darkness, the data is very, very bad. I mean, think about how your eyes work in low light. You're not using your cones anymore, the parts that see color and sharp detail.
Right.
You're relying on the rods, which are great for movement and shades of gray, but the data they provide is incredibly sparse. It's grainy.
Okay, so you get volume, but like zero resolution.
Zero resolution is a good way to put it. So this very limited data stream hits your visual cortex, and the brain just refuses to process it as random shadows. Instead, it aggressively pushes that data through its face template.
And boom, those two slightly lighter spots in the shadow become eyes, and that darker curve underneath becomes a mouth.
It's filling the gaps, yes, but it's doing it with a very strong bias. The brain isn't passive. It actively constructs our reality. And when there isn't enough light, it just overrides the lack of detail by imposing a complete structure onto it.
Which is why it feels so instantaneous. You don't see the shadow slowly become a face. It's just there.
It's an automatic reflex. The information goes through the pareidolia filter, and you get a complete face, even if the physical evidence for it is literally zero.
Okay, so that covers the why of the face. But now let's talk about the feeling. Because when this happens, it's not a neutral illusion. It's terrifying. Your heart rate jumps. That leads to the second big idea in the sources. Is the brain actually trying to save us here?
It is absolutely a survival mechanism. And this links directly to a state called hypervigilance.
Hypervigilance, high alert.
A state of high alert, exactly. It's a deeply rooted evolutionary trait. When the lights go out, or in any situation where our vision is impaired, the brain registers that as a potential threat environment.
Right, because, for most of human history, darkness meant predators or enemies.
Precisely. And this is the core principle the sources really hammer home. Evolution favors the cautious. The brain would much rather commit a false positive.
Meaning, imagine a threat that isn't there.
And be wrong, than risk a false negative, which is ignoring a real threat.
The cost of being wrong about a ghost is a racing heart for a minute. The cost of being wrong about a lion is, well, death.
That is the trade-off, exactly. So this response involves the amygdala, that little almond-shaped part of the brain that handles fear and emotion.
The fear center.
Fear thing. So the fusiform gyrus is screaming, "It's a face!" And at almost the exact same time, the amygdala is screaming, "Threat! Panic now!"
And that's why the fear hits you before you even have a chance to think. The visual ID and the threat assessment happen almost as one, long before the rational mind can go, wait a minute, that's just my towel rack.
The fear is the priority. Your body gets that shot of adrenaline. It prepares to run or fight, all while the conscious part of your brain is still trying to figure out if that shape is solid or just a shadow.
So that classic example, seeing a person standing in the corner of your room.
A shape that is almost always just a pile of laundry or a coat on a chair.
Right.
Objectively, 99% of the time, it's nothing. But because of hypervigilance, the brain fabricates the human form onto that shadow and labels it threat before it even considers coat rack.
Wow. So the illusion is actually serving a biological purpose, even if it's just causing needless panic in my safe modern apartment.
It is. But that brings us to the most unsettling part of all of this.
Okay, yeah. This is where it gets really creepy for me. We've established the static face, the one that's just standing still. But some of the accounts, the ones that really chill you, are when people say they see these figures move.
They seem to approach them, or their
Yeah.
expression changes.
Yes, if nothing is physically there, what on earth is causing the perceived movement?
This is a higher, more complex stage. If the static face is just standard pareidolia, this movement part is what researchers call a visual hallucination illusion. This is where the brain's attempt to stabilize the image goes spectacularly wrong.
Okay, so the brain is trying to stabilize something. What is it trying to stabilize?
It's trying to stabilize the fact that your eyes are never, ever perfectly still. Even when you're staring intently at a shadow, your eyes are making these constant, tiny, rapid, involuntary movements. They're called microsaccades and ocular tremors.
Right, those little jitters that our brain usually just edits out so the world looks stable.
It completely filters them out, yes. In normal light, with high-resolution input, the brain cancels out those movements so your perception is smooth. But in the deep dark, when the only thing you're seeing is that one grainy collection of shadows that your brain has already labeled face, the rules change.
Because there's no other information to go on, it's trying to fill a void.
It's trying to fill a void, exactly. And so the brain receives this subtle, constant shift in input that's being caused by your own eye movements. But because it has already created this fully formed, stable, threatening image, the face, it doesn't interpret those tiny shifts as your eyes moving.
Oh, no.
It interprets them as the illusory face itself moving, shifting, or even drawing closer to you.
Wait, so it's my own eyes making it move. The movement is self-generated.
The movement is entirely self-generated. The face isn't advancing on you. Your brain is projecting your own tiny physiological motions onto a non-existent object.
That is an incredible explanation. You were literally projecting movement onto your own hallucination.
And the brain takes that tiny shift in contrast
Mm.
and immediately translates it into the most high-priority action it can assign to a threat. It's approaching, or its expression is changing. It's a fully dynamic, terrifying scene created from absolutely nothing.
This is the horror movie director at its peak.
Absolutely.
So let's pull all this together. We start with this really common experience of being startled by a shape in the dark. And we've ended up with this really startling realization that the source of the terror is completely internal.
That's the conclusion, really. The source of the fear, the specific image of the face, and even the unsettling movement, it's all engineered entirely inside our own minds.
Your brain isn't just a passive receiver of reality. It's an active producer of a highly specific, personalized, and sometimes, terrifying reality. It's a director.
The most powerful horror movie director in the world, maybe. It takes a few shadows and directs a complete frightening scene for an audience of one.
For you. And that knowledge, it completely changes that feeling of not wanting to walk through the dark house. It's not just a silly superstition anymore.
No, it's not.
It's this deep biological awareness that your own cortex is about to produce a terrifying masterpiece, and you're just trying to avoid having to watch it.
It's a perfectly rational response to a very real internal mechanism.
Which makes total sense, but this also raises a much deeper question for me about our ancient programming.
It does. It really does. I mean, if the main biological job of pareidolia and hypervigilance is to detect threats, which was absolutely essential for our ancestors, you have to wonder, does this ancient programming still serve us well today?
Right.
Or does this overactive internal director of terror just create unnecessary psychological burdens in our modern, mostly safe, well-lit world?
That is an excellent thought to end on. When your brain is so quick to scream threat at something that isn't there, what's the long-term cost of that constant automated overreaction?
It's something to think about, isn't it? The relevance of this incredibly powerful reaction every time you flip a light switch and the shadows get a little deeper.
Absolutely. Well, thank you for guiding us through the dark corners of the mind on this deep dive.
My pleasure. Until next time.